back again with another video. Welcome to this one, Lungile. So we're gonna be looking on exponents. So that's the topic, okay, for this one. So before we go far, we need to understand what are exponents, okay, so that you understand what is the focus of the whole topic, okay. So exponents. Exponents represent repeated multiplication of the same number. I want you to take notes and pay focus to each of these words being mentioned here. Exponent represents repeated, okay? Something has to be repeated, okay? Um, it represents repeated multiplications, not just anything but multiplications, right? Of the same number. It has to be the same number, okay? And it cannot be just different numbers. So that's what exponents are. They represent that. So let me tell you what it means, okay? So any number that exists in this world, okay, it has an exponent, okay. Remember from the previous chapters we were looking to the number system and you talk about whole numbers. It was nice writing numbers two there, you know, 2, 3, 4, all of that. Those numbers, since there's only one two, okay, there's only one two, okay, as in there's only three one three value, there's only one four value. It means there's a way to represent the exponents, okay. Each any number that exists in this world has an exponent one, okay. Any number that exists in this world has exponent one. If I have write 5, it's 5 to the power exponent 1. Even if sometimes the people don't write it, okay. You know that from the lower grades, from previous grades, 6, 4, 3, all of that, you used to write numbers like this. You never worry about exponents, okay, because you know that you just have 1 5. So why you need to, put 1. But you should know now that any number now, it has an exponent 1, okay. So since now we have a third exponent, that means now since we say 5 has an exponent 1, what is this then? This is called a base. So a number now that is 5, it becomes our base, and this becomes our exponent. Okay? This becomes our exponent. So that is what you need to be expecting here. Okay? So it means that for a base number which is 5, it is only appearing once. Okay? That's what it means. So let us look now to how this thing of exponents is actually like done and explored. Okay, so if you look, if you have 2, you remember we have to multiply the same number. If you have 2 times 2 times 2, we are multiplying the same number over and over. Okay, this number, each of them, it has exponent 1. This number can be written as 2 3 to the power of 3. It means that the base number 2 is multiplied repeatedly 3 times. Okay, then you can say 2 to the power of 3. Okay, so those are the rules. We're gonna learn that this actually means that you took one base, which is 2, and add the exponents. Okay, we're gonna talk about that when you talk about the product rule. But just know that exponent tells how many times has that thing been appearing or been multiplied to each other. Okay, that's the example to just have the understanding. So that is the background. Okay, if anyone just gets you out of guard, like, and just ask you what's an exponent, you can explain that. Now there are rules or there are laws that you need to be following in when we have to deal with exponents. There are laws of exponents. This is a very, very important thing. Without this, um, it's hard to go far with math, okay, because this thing actually applies to most of the problems that you're going to be solving. Okay, exponents is a very fundamental thing that you must actually keep in mind. Okay, let us discuss these rules. So we're gonna start looking to what a product rule is. Okay, so a product rule says that if you are multiplying same numbers, okay, you must add the exponent. It's what we just did here. Let's say we have x squared times x squared. It says that, remember, this is our base number. It doesn't have to be a number. Sometimes it can be just a variable. Okay, x squared times x squared. Since these have the same base and you are multiplying, the exponent must be added. Product rule says that you must say take one base, which is x, and add the exponent. So it's going to be 2 plus 2, which is x to the power of 4. That's what it means. Okay, let me check now if you understand what I'm talking about. Let's say we have a squared times a. Okay, I'll give you a second to find the answer. Okay, so now a is not just a. Okay, and you said, you know, that I mentioned that sometimes they will not give you numbers, they will give you variables. Okay, but yeah, you can still use them, so it's like a number. So this variable, it has exponent 1. Okay, so to multiply this, it should be 2 times plus 1. You can take one base and add the exponent, and it's gonna have to be 3 there, a to the power of 3. Okay, okay, now let me just crack your mind. What if you are given a squared times b squared? Can you say maybe this is a squared or a to the power of 4? No, you can't say that. Okay, you can't do anything for this. If someone writes a squared times b squared, you can't add the exponent. Why? Because the bases are not the same. The numbers are not the same. Remember, the rule says that you must have same numbers so that you do the exponents. Okay, so since the a and b are not the same bases, you can't do anything. At the end of the day, we're gonna say the answer here is just simple a squared b squared. Okay, nothing changed. We didn't add anything. Okay, because the bases are not the same. So we only add the exponent if you're multiplying the same bases. Okay, remember, this can just happen. Okay, so you must not make mistakes like that. This thing of adding exponent applies to only if you have same basis. So sometimes this can go far. You can be given more than just uh, one variable. Okay, so for this case, what else? We have 2 and we have 1 here, obviously. So if we add this, we're gonna have 2 plus 1, 3. Then this 2 plus 3 is gonna 2 plus 1 is 3, and that plus 3 is 6. So the total answer is that. Okay, so you can see that you must have the same basis so that you can take one base and add the exponent. That is a product rule. So let me just crack your mind again. What if now you're given different variables, but now some of them are similar, okay, or are the same base? Let's say you are given AB multiplied by B. Okay, first of all, you must know that this is power of 1, this is exponent 1, exponent 1. So what you can do, you focus only to the bases or to the numbers that are the same. A is not the same, so you can write A as the same as to the power of 1, like that. So since B and B are multiplied here, but they are same basis, you can take 1 and now add the exponent. So you're gonna have 1 to the power of 1 b squared. Okay, I hope you see that. Okay, so we always focus to the ones that have the same basis. Okay, let's make another example of something like this. take down of these examples because they are very important. They make you understand this deep. Okay, so if you have ABC times maybe BC times AB, okay, what I need to do is just look to the same variables. First of all, make sure that you know all the exponents. So the exponents are 1, 1, 1, 1, 1, because yeah, we're giving like that. So first focus on A. We have A and A. They are the same. So we're gonna have A, take 1 and add the exponent. You only do this if when you are multiplying. That's why it's called a product rule. We have B and you have B and you have B. There are 3 B's and the exponents are 1. So you're gonna be 1 plus 1 plus 1. How many C? We have this C and this C. So it's gonna be C1 plus 1. So it's gonna be A squared B to the power of 3. If you add C squared. So you can see that you might focus to the ones that have the same base, you add their exponents. Okay, I hope this is clear now. Hope this is very clear. Okay, product rule only for multiplication. Only for multiplication. You add the exponent if you are only multiplying. Okay, okay, only for multiplication. That is what product rule is for. Okay, take note of that. So let's move on. We have another rule. These rules you must know them by head, by the way. Okay, and the second rule is the quotient rule. Quotient rule, it has to deal with division. Division. It has to deal with the division. Okay, so let's deal with it. A division means we are dividing two quantities. Okay, so if you have A squared divided by A, what does it say? It says that you should take, if the bases are the same, make sure that the bases are the same numbers. You take 1 and subtract. Okay, remember the power here is 1. You subtract what? You subtract the 1 at the top minus the 1 below. So it's gonna be 2 minus 1, and it's gonna give you A to the power of 1. Do you see that? Okay, that's what quotient rule says. That if there is division, what can you do with the exponent? You must subtract them. Okay, only if also the numbers are the same. For example, if you are given A squared divided by B, you can't do anything to this because the bases are not the same. Okay, you can't do anything to this because the bases are not the same. So this applies only if the bases are the same. Okay, now what if you are given another scenario which is a bit complex than that one we discussed? Let's say you're given xy maybe to the power of 3 divided by maybe y. Okay, so what do we do? What we do is that we focus on the one that has the same. Okay, so we're gonna have x, we leave x like that, then we focus on this. Since we have this, okay, since we have this, we're gonna have y. What did we say? The power of 1 here is 1, right? So we're gonna subtract 3 minus 1, x squared, right? Yes. So this is what you have. So you remember to focus only on the same variables. On the same variables. Okay, so okay, let me just go back to what we just discussed here. I want to make sure that you understand why we just brought x like that. Okay, so we had, what did we have? We had 4 to the power of 3 here over y squared, right? Oh no, it was just y. So and we said we should put 1 here. Okay, so why did we leave x and we dropped x? We don't just drop x. X was above, which means x was still above and there was something below. What was that? Since there's no any other x, we have just put 1. Okay, then let us deal with this, the one with the same. So we said since here we have y over 3, I mean y to the exponent 3 over y to the exponent 1, so it's gonna be take y and 3 minus 1. Anything divided by 1, x divided by 1 is x. So that's why we had that on our previous example. It's because x is above. Okay, and since there's nothing matching to x, we put 1. Keep that please. Let's say we have another case. Let's say we have x, y, z over let me just write it like this. Let's say we have y z squared divided by x y. Okay, what to do here? Let's focus on let's focus on x first. X, it's only appearing below, we don't have x below above. So what you're gonna do with x variable, you're gonna say there's 1 over x. Okay, then let's get to another one. Let's deal with y. Y is appearing in both sides. Okay, which means we can say take y first, 1 only y, 1 as base. Here it's 1, so since we are dividing, we're gonna minus 2 minus 1. Z squared, it's only in above, we don't have it's below, so we're gonna say z squared, what is below is nothing, so we're gonna put 1. Okay, here 1 over x, you must know that 1 over x, we're gonna still discuss this. 1 over x, remember the x below is 2 power of 1, it's the same as x to the minus 1. Why? Whenever you have 1 over x to the power of 1 or power of something here, it's the same as having x, but that now is negative. Okay, so that's why we have a negative 1 here. We're still going to discuss that. And here 2 minus 1 is 1, and z squared over divided by 1 is just going to come back as z squared. So that is quotient rule. Remember again, you only deal with the ones with the same variables, and that's where you subtract the exponents. The ones that are not comparable to any other, same with other any variable below or above, you leave them like that. Remember that if it is below, you consider as the numerator to have 1. If it is above, you consider the denominator to have 1. Okay, please make sure of that. Now let's get to another rule called power of power. Okay, power of power means that what if you have a number that already have an exponent, but on top of that exponent there's another exponent. Okay, so it is power of power. So what it means, let's say you have 2 to the power of 3, but with having this there's another exponent above. Let's say it's 2. What can you do now if you have such problems? It's easy. It says that if you have a to the power of m exponent n again, okay, a, you can take one base, which is 2, then you can multiply the exponent. Whenever there are exponents above and above, you just multiply them. Okay, you don't add, you multiply them. So you're gonna say 3 times 2. If you have a power of power thing, you say 3 times 2. So this gonna be 3 times 2 is 6. Okay, so you're gonna have 2 to the power of 6. Hope this is clear. Let's say you have x squared to the power of 4. Okay, and this could be 2 times 4, which is x to the power of 8. Simple. Okay, so that's what you do. Power of power, you just multiply the exponents. Okay, we have another rule or another law called the zero exponent. The zero exponent is very simple. Anything to the power of 0 is 1, is equals to 1. Only if a is not 0. Okay, so if you have 2 to the power of 0, this thing is 1. If you have any number of 0 is 1. Any number, a to the power of 0 is 1. X to the power of 0 is 1. Y to the power of 0 is 1. You must know this. You must know this. Let's say you have a different problem. Let's say you have xy divided by y. What did you say? We have x. Is it having another thing comparable below? No. So it's going to put 1. We have exponent 1 here and exponent 1. So we're going to take y1, first only 1 y. And exponent, what do we do? Since we divide, we minus them. Okay. So we're going to have x. Here y, 1 minus 1 is 0. So we're going to have that. So this is equals to 1. So you just like multiplying by 1 there. It's the same thing. So y to the power of 0, anything to the power of 0 is 1. So that's why you're going to have x. Okay, that's why you're going to have x. X times 1 is 1, is x. Okay, so that's it. This is another rule. Okay, it's called a negative exponent. I think we just discussed it. It says that if you have a to the minus n is the same as 1 over a n. Okay, why? Whenever you have an a to the exponent, negative exponent, it's the same as like having 1 over the same thing below, but it being positive. Okay, which means if I have 2 to the exponent negative 1 is the same thing as 1 over 2 to the exponent 1. Okay, if I have x to the minus 2 is the same thing as 1 to the x squared. Okay, okay, so this is what a negative exponent means. Has a like before. So what if we have, for example, let's say we have 1 over x. We said since this is power of 1, this is the same as x but negative 1. Okay? If we have maybe exponentially here, it's the same thing as x but minus 3. Okay, yeah. So sometimes in some problems like before, you can be given maybe something like this. Right, so you're gonna say, where is x? X is above, it means below it's 1 because there's no other x. Where's z? Z is above, there's no other z below. Where is y? Y is below. That means there's 1 above. Okay, so this thing is the same as x. X divided by 1 is x. Z divided by 1 is z. 1 over y. Now you need to know the exponent here, which is 1. So it's like y minus 1. So this is what negative exponents mean. Okay, so feel free to just pause the video so that you understand. Take it step by step, try to think through it and understand what I'm actually explaining, so that you can easily apply this thing when you are solving many other problems. Okay, let's check some examples here. Okay, so in this one it says that you are given squared times 5 cubed. Okay, and this same basis, so you're gonna take 1 and add the exponents, right? So you're gonna get what, 5 to the power of 5, right? Yeah, so 5 to the power of 5 is equals to this 3125 if you check in your calculator, but this answer is enough. Okay, let's look to another case. Okay, so here we have 6 to the 2 to the power of 6 divided by 2 to the power of 2. We know that you can write this again like this, right? We know that. So since the bases are the same, you can take one base minus the exponent. Remember, you minus the top, minus the below, minus the one in the below. 6 minus 2. 6 minus 2 is 4. 2 to, okay, then you're gonna have 2 to the power of 4. This is what you have. Okay, simple. That is our quotient rule. Then let us revise our power rule. Rule, it says that we have 3 squared, but now there is another power of 3. Remember what we said? You said we take this one base, which is 3, then what do we do with this? We multiply them, right? We said we multiply with the 2, so we're going to have 2 times 3, and it's going to have power of 6, right? That's it. That's how you get this one. Then let's look to the zero exponent rule. We have 7 to the power of 0. We know it's equals to 1. It's very simple. Okay, what else? We have our negative exponent rule. Negative exponent rule, you are given 10 to the power of negative 2. They ask you what is it equal to. It also equals to 1 over 10 squared. Remember, we can say 1 over something, but now the exponent is positive, right? 10 squared is also 1 over is also 100, so you can simplify this further, but having this is enough. Okay, hope you understand the negative exponent. We just discussed it before. Okay, now let us look to this last number 6 problem. Okay, it's not the last, but yeah, it's almost the last. Okay, okay, to this last problem, this is what we're gonna have. We are given 2 to the power of 3 times 2 squared. All of this divided by 2 to the power of 4. Can you see now that we have a bit complex? Okay, So what we can do, you can write this in another way. You can say we have 2 to the power of 3 times 2 to the power of 2, all of this divided by 2 to the power of 4. Okay, so what you can do is to solve maybe the parts at the top. We see that here we have the products on top and the bases are the same. You can just solve the top first. Okay, product rule first, right? So on top you can take one base and add the exponent. Remember, since you are multiplying, you're gonna have 3 plus 2. Remember, below you only you still have 2 to the power of 4. Here you're gonna get 5 when you add 3 plus 2. Remember, below you still have 2 to the power of 4. Now you have to solve this. To solve this, you're gonna have to take one base, and what do you do? Subtract the exponent since you are dividing. 5 minus 4, and this will give you 2 to the power of 1. How easy is that one? It's very, very easy, right? Yes, very, very easy. Okay, check it. Okay, take your time. Okay, let me make another example similar to this one by myself. Okay, then I'll give you maybe just a small problem to just do it for your practice so that I check it. A very simple one. Okay, so if you have x y squared times yb all divided by a b x squared. Ooh, okay. Remember, first try to solve the denominator alone and solve what's the rest as you carry on. So what is happening here? Do we have some similar variables? Yes, we have. We have y and y is the same, but x and b are not, they don't have the similar variables, so we're just gonna leave them for now. So we're gonna leave x and b, but we're gonna deal with these two. So here we have exponent 1. So what you can do here, since you are multiplying, it's gonna be 2 plus 1. Remember, below we still have abx squared, and we're gonna have xb on top, y to the power of 3, abx squared, right? Simplify it now. So let's solve this further. What do we have here? We have b. Okay, let's start with x. We have x and x here, so we can take 1 and subtract. So we're gonna have, this is the power of 1, so it's gonna be 1. Remember, we take the exponent minus the 1 at the below. Okay, what about a doesn't have any friend on top. Okay, so we're gonna have 1 over a, put 1 on the top. What about y cubed? Well, it doesn't have any friend on top, so you're gonna have y to the power of 3 over 1. What about b? Oh, b has a friend on top and below. Okay, so they're gonna be we're gonna be checking their exponent. Then we're applying the quotient rule, then 1 minus 1, right? 1 minus 1. Okay, so let's simplify this. So x to the power of 1 minus 2 is going to give you x minus 1. If you say 1 minus 2 is going to give you minus 1. Then 1 over a. Remember, it's 1 over a. What is power of a here? It's 1. So this is the same as a minus 1. Y cubed over 1. Anything divided by 1, it comes up the same way. b, 1 minus 1 is 0. So we know that this equals to 1. Okay, so anything, we are applying all the rules here. So simplifying this, anything multiplied by 1 is gonna same way as x 1 a negative 1 y cubed. That's our answer. Okay, this is our answer. So keep that in mind. Keep that in mind. Okay, another thing to look on. Let's check what. Okay, let me give you a challenge problem. Let me give you a challenge problem. Okay, give you a challenge problem. Okay, a challenge problem is that if you have pyz yq times qp all divided by simplify this, okay, simplify this and tell me the answer that you get. So we're gonna discuss it when we meet again. Okay, so make sure to cover that one. Okay, um, let's look to this problem before we end the video, but don't forget to do this challenge problem. Okay, we have the question here given to us. It's question 4, and it says choose the weight for those given brackets. So it says exponent or expressions are a shorter way of writing a repeated multiplication of the same number by itself. So we know that the correct answer here is exponents. We said it's the representation of the repeated multiplication of the same number. So exponents. I'm going to choose exponents. Okay. So that's the answer. Okay. Here we are given PQ times PQ, and they ask us if this is correct. Before we say it's correct or not, let's check it. PQ times PQ. What did we say? We only multiply those who have the same bases and add their exponent. So this is 1, this is 1, this is 1. So P times P, you can take 1P and 1 plus 1. Q, you can take 1Q and 1 plus 1. So you can have P squared, Q squared. This is the correct answer. How is this one? This one is P Q squared. It's not the same as this one. So this is wrong. Okay? This is wrong. Then let's look to this one. Here they are trying to trick us. They're asking if x plus xy plus xy is the same as xy squared. Okay, let's see that. So if we have, we're gonna check the left hand side. Okay, first xy plus xy, what is it equals to? Remember when we were dealing with algebraic expressions, we said when you have such things, when you have the same set of variables, we can add them and add their coefficient. So the coefficient here is 1 and the coefficient is 1 here. So xy plus xy is like 2xy. Okay, what is xy squared then? We have checked the left hand side. Okay, the left hand side is this. Let's see what about the right hand side. Okay, so xy squared, remember This is like the power of power rule, okay? Because inside here we know the x is 1 and that is 1. What did we say? We said this exponent will multiply these exponents. So we're going to have x 1 times 2, y 1 times 2. So we're going to have x squared, y squared. This is our answer. So is this equals to that? No. Okay? We can see that. So the answer here is this equals to this. You can see this equals to 2xy. This is equal to x squared, y squared. So this is wrong also. Okay? This is wrong. Then let's check the following question again. Pay attention to these things I'm doing here. If ever there's something that you don't understand, go check back to your notes and see how did I work out. Okay, you must have discipline to find the things that you understand. Okay, now we have 5 to the power of 4 times 1 to the minus 3. So what you can do, you can multiply this. If you multiply this 5 over 4 to the numerator, remember 5 over 4 it can be the same as 5 over 4 over 1. Okay, so 5 over 5, not 5 over 4, I mean 5 to the power of 4. 5 to the exponent 4 times 1 is 5 to the exponent 4, right? Then divide that 1 times 5 over 1 times 5 to the exponent negative 3. It's gonna give you back the same thing. Okay, so when you solve this, remember what we said. We said when you divide, you must subtract the exponent. So it's gonna be the one at top 4 minus, remember there's a minus because you subtract. Then minus the one also we have which is minus 3. Okay, so this, if you solve it, go check in your calculator, it's gonna give you 4 minus 3. It's gonna give you what? It's gonna give you 7. Okay, so here they said, is this equals to 5 to the exponent 1? No, it's not. So when you solve this thing, it doesn't give us 5 to the exponent 1. So I think we have checked that. So you can see someone who just guessed in this question can get a lot of questions wrong. Okay, you can see here, okay, they try to give you the correct answers as we discussed. Now let's just look at the last one before we finish. Okay, I wanted to write this on a new page so that we understand it clear. Simplify this. Okay, we have eight r cubed, this dot means multiply, times 2r squared to the power of 4. All divided by all divided by 2 to the power of 4, r squared to the power of 5. R what? R squared to the power of 5. Okay, done copy. So what can you do here? Simplify bit by bit. So what you can do, you can try to simplify this first. So we have 8 r cubed 2. Remember what we said? You said you must multiply this power of power. So 2 times 4 is 8. Here, what we do, we multiply the powers, power of power, right? 5 times 2 is 10. Here, what you must know, we have numbers and we have variables. Numbers, we multiply them all together. So we have 8 times 2. 8 times 2 is 16. What do we do? We are multiplying r cubed multiplied by r to the power of 8. What did we say when you multiply? We add the exponents. 2 to the power of 4. Okay? Then we have r to the power of 10. This is gonna give us 16. When you add this, what you get 11. 3 plus 8 is 11 over 2 to the power of 4 r to the power of 10. Okay, now we need to simplify this. Remember, since we are simplifying, 16 is a big number, it's not in terms of exponents, so we need to change it. How to change it? Your calculator, press 16 equal sign, shift, press the button with the facts. Okay, remember how we used to do that with the facts. Okay, if you press that button, it's gonna give you 16 is equal to the 2 to the power of 4 actually. Okay, so let's carry on, which means here we're gonna have 2 to the power of 4, which is like 16, r to the power of 11 to the power of 4 r to the power of 10. Okay, so when you solve this, we're gonna have what? We're gonna take here one base and minus the exponents, right? Constant dividing. For r variables, we're gonna take also one base, then minus the exponents. We're gonna have 2 to the power of 0. 11 minus 10 is 1. Okay, then we know any 2 to the power of 0 is like 1. We know anything to the power of 0 is 1, and you're gonna have r to the power of 1. So this thing 1 multiplied by r is like r. So this is our final answer. Okay, so follow the steps and make sure you understand every single step. Look, also the answer here mentioned is r. Okay, so this is all what we had for this topic of exponents. Don't forget to this challenge problem I mentioned. Okay, that's all. Cheers.